Good morning, everyone. I know that it was a conference dinner last night, and probably as a sizable subset of you had a little bit too much to drink, but I'm just going to dive right in to where I picked up where I left off last time. So, to give a bit of a recap, what I'm going to be doing, and hopefully sort of finish off today, is thinking about how the way that physicists understand fundamental theories, at least in the context of quantum field theory, has some really interesting, or potentially some really interesting metaphysical implications, right, for those of us who care about metaphysical issues. Right? There's a very rich theme to be mined there. And the issues that I'm going to focus on, I think I'm not going to talk about structuralism, given that we didn't even finish the modality stuff last time. The issues that I'm going to focus on are what these fundamentality considerations from quantum field theory suggest about the kind of the modal landscape, right? That one might embed our sort of theories in, and secondly, how it is that we actually think about what it is to be fundamental. So I'll hopefully get to that second issue pretty soon. Now, both of these claims that I'm going to make. So my claim with regard to the modal stuff is that fundamental quantum field theories present us with this offer to unrecognized metaphysical possibility, or at least it's certainly not. If it's recognized, it's definitely buried within the literature somewhere. I can't think of anybody who's argued for it. That one can be a Humean, at once a Humean, and believe that the laws of nature are actually metaphysically necessary. So we haven't really seen space for that kind of view before. But I think it's a very natural interpretation of quantum field theory. Both of the claims that I'm going to make, that's going to be my claim about the modal stuff, and the claim that I'm going to make about how quantum field theory changes our conception of what's fundamental is that it suggests that the fundamental might be the sort of thing that you can explain. Okay, so this is pretty radical because metaphysicians tend to sort of analytically equate that which is fundamental with that which has no explanation. So I'm going to point towards that later on. Now, both of these claims that I'm going to make are going to revolve around two requirements that we managed to that we pointed out last time on fundamental theories of quantum field theory within the context of quantum field theory. So just to recap what these are very, very quickly, I talked about two requirements on these theories, and we gave a kind of an intuitive derivation of where these come from. All that was intuitive really was that if a theory is going to count, if a theory of quantum fields is going to count as fundamental, i.e. consistent even in the limit of arbitrarily large energy, then it's going to be a pretty special theory, right? You wouldn't a priori expect any theory to have a property like that. Too many balls to keep in the air. So what are those properties? Well, like I said last time, we don't, I think, at the moment, in fact, we don't have any completely general results for any fundamental quantum field theory. We have them for a special case, the so-called asymptotically free theories, which are theories in which the interaction couplings don't just, which codify the strength of interactions, they don't just stay finite, but moreover they tend to zero as energies get arbitrarily large. So it really is a special case, but I'll talk about how general this argument is a little bit later on. Nevertheless, for kind of computational reasons, we're going to use them as our model of fundamental theories. All right, and certainly they're a case of fundamental theories, so that this is a possibility isn't really affected by the lack of generality of this argument. So the first requirement on these theories is that the theories have to be a non-abelian local gauge theory, right? AKA a Yang-Mills theory. They may have heard that. So I won't talk about too much about what exactly that means. I gestured at it last time. The significant thing for our purposes about these theories is that when you have, say, a theory of fermions, a theory of free fermions, and you say, well, if these guys are going to interact and I'm going to have a fundamental theory of these things, then it suddenly appears in the process of making that theory gauge invariant that bosons pop out, and the form of the interaction between these fermionic fields and the boson fields that mediate the interactions is basically determined for you. It's going to be very important. And the second requirement is that there's a kind of upper limit on how many fermions you can have featuring in your theory. So we gave an example of QCD. So QCD is, people say it's an asymptotically free theory, it's the only candidate we have for a truly fundamental theory, but that claim is actually not unconditional. Right? It turns out that if there were more than 16 kinds of quark, then that would no longer be the case, which is a kind of weird result, but there it is. Okay, so there's 6 there's 6 known kinds of fermion, right? We only know there's another 10. But there can't be more than 10. Okay, so this second requirement gives rise to what I've called the Goldilocks principle for fundamental things, which says that whatever the actual, according to quantum field theory, whatever the actual inventory of fundamental fields is, it'll take something like this form. Sorry about the graphic notation. There'll be some number n of bosons, some number m of fermions for some n greater than 0, with a strict upper bound on m, and with n and m related by the mathematics of the symmetry group, but we're not going to focus on that relationship here. That doesn't really matter so much. Okay, so these are 2 requirements. Now, the first of these requirements, the requirement of local gauge symmetry, I argue has implications for modal theories, and as I say, suggest that they space for a Humean necessitarianism. The second requirement, right, the Goldilocks principle, has implications for, well, actually the Goldilocks principle is a kind of fusion of the 2 requirements, isn't it? But certainly the Goldilocks principle has implications for structuralist metaphysics that I won't talk about. More interestingly, I think, the concept of fundamentality. I'll talk about those 2 today. Okay. So I'm trying to argue, first of all, that there's some interesting and kind of rich models seem to be mined here. Okay, so here's that quote from David Lewis again. So David Lewis is the kind of the architect of the most influential Humean theory, right? The best systems analysis, right? Which is basically, if you're a contemporary Humean, you tend to buy into this in one way or another. This is one way that, so according to, because it's a Humean analysis, it says that the connections between properties that are actual laws of nature have to be regarded as wholly contingent. Things happen to be related that way, it seems, but they could have been otherwise. There's no natural necessity in the world forcing other properties to appear when some other properties appear, and so on. And David Lewis supports this, or in some ways, one way of expressing that Humean intuition is in terms of the principle of recombination that just says it's metaphysically possible for any combination of properties to be instantiated in some world or other. I talked a little bit about this last time. So here's something that he says. I support the denial of essential nomological roles, the sort of thing that the dispositional essentialist is committed to, right? It's of the nature of charge to be such that were you to short another charge, it sort of putters off at whatever acceleration. I support this denial by means of the principle of recombination. Start with the worlds, where the quark colors and flavors do feature in the laws that are supposed to be essential to them, right? So you might as well say, start in the actual world with the quark colors and flavors behaving in the way that they actually do. Dispositionalists are going to say it's essential to them to do so. Okay, so start in the actual world. Now, patch together duplicates of things from that world, and presumably you can describe a world where those laws are broken, right? Laws say what patterns of properties follow other patterns of properties. If you can recombine those properties into arbitrary patterns, you are ipso facto describing a world with different laws. Okay. So he's explicitly, I mean, he's exposed himself here, right? Because he started talking, he's using this jargon from contemporary physics, which is quite right, because he's a physicalist, and hence he thinks the fundamental facts and properties are all physical facts, right? So that seems exactly right. In fact, he's picked a good example, because the quark colors and flavors do feature in laws that we think are likely, or good candidates for being fundamental, and it's fundamental laws that everybody's interested in. So let's ask ourselves what the quark colors are, okay? Well, ask a kind of layperson's answer here, we'll tell you what the quark colors are: red, green, and blue. These are determinants, if you like, of the determinable property color. But of course, these aren't red, green, and blue in the sense of the electromagnetic spectrum. They have a totally different meaning in this context. And if you want to find out more about them, then you would go and you would ask a physicist. And what would the physicist tell you, right? As a matter of fact, in their parlance, what is it that they understand by these notions of red, green, and blue? Construed as properties of fundamental fields. Well, they say, well, these are just names for the basis vectors of a fundamental representation of the SU3 group. Right, that's what they would tell you. Now, what does that mean? So, I'm not going to go into any detail about the mathematics of symmetry here, or group representation theory, or anything like that. So let's suffice to sort of say the following. To say that red, green, and blue are just names for the basis vectors of a fundamental representation of an SUN group It's just like saying that these properties are formally at least just like spin up and spin down. Okay? So just as you can express all the spin states of an electron in terms of superpositions of spin up and spin down states, you can express all color states of quarks as superpositions of these three colors, red, green, and blue. Okay, that's something that follows from the fact that we regard these as basis vectors of a representation. The fact that they're the basis vectors of not just that, a fundamental representation of this group means that all color states of systems that are composed out of quarks will also similarly be expressible in terms of these vectors, right? So they'll be, because they're in the fundamental representation, so hadrons are going to be non-fundamental particles, are going to be non-fundamental representations, the things that we can build out of fundamental representations by definition, just mathematically. And that seems exactly right. That's what it is to be a non-fundamental particle, to have its state kind of built up or determined by states of more fundamental particles within it. So there should be something, again, I'm not going to talk about the mathematics of symmetry too much. Basically, if you don't already know this stuff, I'm not the person who should be teaching you it. And if you do know it, then there's no point in me talking about it. But I'll just kind of suffice to say that that these, to think of red, green, and blue, the determinants of color in this way, is very analogous to thinking about them as formally at least, as along the lines of the spin of a fundamental particle. So just as you build up the spin state of, I don't know, deuterium atom or something from the spin states of the components, like I said, you're going to build up the spin state of a strongly interacting hadron, a non-fundamental particle, by thinking about the color state of a non-fundamental particle by thinking about the color states of the constituents within it. However, it's really important to note that you're not going to be able to do this unless you take into account facts about the relevant group theory, right? So like a quote from John Baez, the physics of color is not understandable if all you know is that there's three colors. You really must understand something about the mathematics of the relevant symmetry group. Otherwise, you're just not going to get the right answer. Right? So the symmetry group is extremely important when you're doing physics. Okay, so in saying that physicists understand these colors that David Lewis had mentioned, about the quark colors and flavors, by saying that they understand these as basis vectors in a fundamental representation of the SU3 group, they're clearly imparting some mathematical structure to this property. I haven't said much about that structure, but it's clearly mathematical language, and it's being attributed to the property itself. Now, there is nothing new in this. Okay, so last time I made a big deal of the fact that David Armstrong said, look guys, you can't just think of laws along the lines of all F's are G, all ravens are black type characterizations we got from the positivists. You need to pay attention to the fact that they're mathematically expressed. Presumably we have to do this only if there's significant metaphysical material to be got out of that pretty elementary fact about mathematical physics, and the fact that the implication that he draws from it is that universals pertaining to fundamental physical determinables like mass and charge have a certain structure within them, right? They have a structure that is isomorphic to the real line, in fact. Right? This gives rise to his theory of structural universals. For him, that's the only theory of universals that can really make sense of physics, right? And so there's this kind of isomorphism between how the mathematics between mass as it is represented in physics and the structure of universals themselves. So in saying that we're giving some mathematical structure to the property of color, we're not doing anything new. Other people do that too. Yeah?
I was wondering, like, is this, how's this different from Platonism? To say that there were like mathematical structures in Platonic heaven, is that a very different thing to saying that there are structural universals?
So, I mean, his theory is a sort of, it's a kind of Platonist theory. He's not a Platonist, he's more like an Aristotelian in that he thinks there's no uninstantiated universals. But yeah, it's a theory of universals. Up there.
So I won't go far wrong thinking about that.
No.
Okay, please.
Yeah, no, it's Platon. Yeah, sure, it's Platonist, right? I'm wrong. It's just that, so I'm getting a little defensive. Anybody says, how is this different from Platonism? This is also not my theory. Okay. But yeah, no, it's pretty, yeah, it's like massively like Pythagorean. Yeah. Okay, so there's nothing new in sort of attributing a bit of mathematical structure into a property. It's just that he has a really sort of literal understanding of this, like how to make sense of this. It's like the mathematics is translated into like a part-good relation. Like this thing, just like this thing has, you know, parts or whatever, so does that. And of course, people attack, David Lewis famously attacked this. But there's nothing new in thinking it's okay to have a bit of mathematical structure when getting it right on fundamental problems. Anyway, point for present purposes is that by saying that there's a bit of mathematical structure sort of needed to understand this property of colour, you can immediately determine that the symmetry of the laws that any particle with those properties can feature in has to have the symmetry of SU3. Right? By saying that quarks, the property of colour, is a basis vector in a state, is a basis vector of a fundamental representation of the SU3 group, tells you that those states have to feature in laws that are also invariant under the SU3 group. Now, if you know a bit about group representation theory, that's just like, it's like trivial, like that's like a kind of an analytic claim. But for those of you who are not familiar with this, let me just try and make it a reasonable thing to think. Right, so here's a little picture. This is a little picture of the fundamental representation of the SU3 group. Now, physicists are going to, or people that, if somebody with a bit of facility with group theory is going to be able to take one look at that, partly because all the groups have been sort of categorized, and say, oh, that's the fundamental representation of the SU3 group. Right, not because it has these three colors on it, those are just provided for you for your entertainment. Right, what's relevant about these things is the angle between these vectors and the relative lengths of these vectors, right? These are what's going to be used to classify one of these diagrams as pertaining to a different, one or other symmetry group. Now it should be kind of understandable how we can go from this little graph, this little picture, to the symmetry group, because what this thing represents is actually a set of solutions to a series of equations that are characteristic of the group, namely the algebra. I'm going to gloss over that distinction. Namely the Lie algebra associated with the group, right? So this is in some ways a kind of a picture of a set of solutions. Just like a graph is a picture of a set of solutions to an equation, okay? And just as you can use a graph to determine what an equation is, there's a kind of one-to-one correspondence between them, the same thing is going on here, right? Similarly, you might have heard of the Erlangen program, right, in which geometrical figures are classified in terms of symmetry groups. Here is a kind of geometrical figure. Right? From that geometrical figure, we're able to work backwards and say, well, this is the symmetry group. Okay, so there's this very intimate correspondence between one of these diagrams, right, a set of basis vectors of the SU3 group and the group itself, and the symmetry itself. Okay? So by telling a physicist, right, these are the properties that I have, thereby give them a bit of group theory, they're able to say, well, this is the symmetry that laws of particles with these properties have to have. Now, in general, knowledge of the symmetries that a law has or that an equation has does not suffice to determine it uniquely. Okay, so if I tell you I've got a theory of electromagnetism, or say like a theory of some electromagnetic potential, it is spherically symmetric. Right? So you know that your Lagrangian that's going to describe interactions with this potential is going to have a spherical symmetry associated with it. That doesn't tell you, for example, what the radial dependence is. The radial dependence can be pretty much anything consistent with that. So just that information doesn't tell you exactly, doesn't pin down what law, the relevant law of interaction is. But things are different here, because if I also tell you, which is postulated here, that colour is a fundamental property, I know, well, so far I know that the law has to have the symmetry SU3, but also it needs to be a fundamental law. So I also know by the previous argument that it's got to also have a local gauge symmetry. And that, as I said, is going to pin down the law uniquely for you, right? Because by saying that the law is going to have a local gauge symmetry, the boson pops out and the form of the coupling between the couplings between the quarks and the bosons and the coupling strength, like everything that's relevant to an interaction is thereby given to you on a platter. Okay, so this is something we said before, right? You start off with the free theory, you realize, you say, oh, this is going to be fundamental. This is a bunch of, sorry, there's a massive centipede there that I want to you start off with some free particles. You say, I want with color, I want these things to be interacting. You then say, write me down a local gauge theory. Oh, by the way, the symmetry of that local gauge transformation has to be SU. The group associated with that local gauge symmetry has to be SU3, and boom, I know how to write it down. Out pops my boson, out pops the coupling, and Bob's your uncle. We have the formally interaction determined. Everything's done for you. Okay, so that's what a physicist would think. Oh, if you've got fundamental particles with color, then I can write down the Lagrangian for you, boom, 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 look at all these cool things we can do with it, right? I'm saying that this is a really significant metaphysical import, because you can see where I'm going with this. Give me the fundamental parts, give me the colors, and I can write you down a law. So in any world in which I have duplicates of these fields, I have the same law, and by the same if quantum field, if these are quantum fields. And so in every world in which we get the duplicate, we get the same law. And a kind of necessitarian seems looming. Yes?
Yeah. So I see how this is going to work out, but I'm worried that if you're a human, you're going to say, well, it depends on your definition of boson and fermion. And presumably in other words, where you define bosons and fermions with other mathematical properties,
right.
Many of these results might not hold. So.
Right. So yeah. So this is. I mean, yeah. This is exactly what I'm going to say here. Right. So let me try and address that. So. All I've said so far is just parroting physicists, right? And physicists are interested in the way that, well, they're interested in other counterfactuals as well, but primarily, you're interested in finding out and describing the things that are in this world, and then but what I'm interested in, what goes on in all these other possible worlds, where we have these duplicates, right? So you might say, well, maybe it's just contingent, right, that color is associated, these three colors are associated with the SU3 symmetry group. So it's really only if I deny that, if I think it's a necessary feature of it, that I can run this argument. So it's clearly completely crucial, but there's a bunch of things to say here. So first of all, there's just a mathematical problem that I haven't sat down to kind of look at. Find me some other groups that have three-dimensional fundamental representations and make sure they are the sort of thing that could feature in a local gauge theory. Right? We have three colors. In any world in which there's quantum fields, right, there has to be local gauges. So I suspect the answer to that is no, but I haven't shown it. Right? So there's a perfectly, so as I say, I have a foot in both camps. I think that I'm kind of attracted to humanism insofar as I think the postulation of natural necessity doesn't really do any meaningful explanatory work. I think that the denial of that there are necessary connections in nature is a completely coherent one. There are no kind of objective constraints in nature is perfectly coherent. What I don't like is how that gets translated into the idea that there's no constraints on your theorizing and you can say whatever you want. Right? I can say, oh, colour can obey laws with arbitrary, this, that, or the other. I'm a human, of course I can deny that. That I don't think is respectable. Right? One has to do more work than simply say, oh, this could be contingent. Show me. Right? So another thing that we'll see, we'll get to that. What I'm going to say, all I'm going to say to defend myself at this point is that Humeans have done this too. Right? Think Armstrong. He's again a kind of got a weird sort of position, but it's but certainly he thinks that fundamental properties are categorical. Right? They are properties are in themselves don't point out towards, don't have implications for laws. In some sense. We talked a bit about that last time. And yet, he's happy to go from the fact that, mass is represented as a continuous function to saying, oh, mass has this mathematical structure associated with it. And by the way, that universal shines down the same way in all these different possible worlds, right? We've got one property that governs, that is, available for work in any of these possible worlds. If he can do it, why can't I? So part of this is just a plea, what are the rules for the game? When can I say that when can I identify some mathematical structure in a property simpliciter, right? And when do I say, oh, this is just a contingent feature of it and so on? I don't know what the rules of the game are, but if they can do that, so can I. Okay, so now you see where we're going. If it's okay, if it's kosher for me to say, this mathematical structure that is completely essential to the physics of color in this world is a is a necessary feature of it, right? It's just a feature of the property, right, and not just some little sort of guise that it's wearing in this possible world. Then you can see how we get to this Humean idea of a kind of necessitarianism, right? So let's not call it Humeanism. Humeanism looks like it's in trouble actually, because now it's beginning to look that the laws are not contingent. Whenever you have these part duplicates, we can run the argument and we get the laws, right? Hence the laws, in that sense, are necessary. Sometimes this is called weak metaphysical necessity. It's not that these laws hold in every possible world in the way that 2 + 2 = 4 does. It's conditional. Wherever you have, in any world in which you have these fields, you have these laws. Also, it seems that the idea that the fundamental properties are categorical, i.e. free of gnomic implications, gnomic commitments, is also a bit dead in the water. On the contrary, given the work that symmetries do in physics, given the very stringent constraints on fundamental theories, if I tell you what the fundamental properties are, in this context, they're absolutely replete with nomological implications. Okay, so humanism looks like it's in trouble. However, seems like, I haven't gone through this math, I'm just trying to make it as intuitive as possible. But it seems that the fact that fields with given properties cannot be solutions of equations with arbitrary symmetries, it's just that if anything, it's a fact about the mathematics of symmetry, right? It's a mathematical argument that you're going to run to show that. Similarly, the fact that any fundamental theory must have a local gauge symmetry is a mathematical consistency requirement on a fundamental quantum field theory. Right? Assuming that unitarity is a principle that we have to respect, then there's massive constraints, mathematical constraints on a Lagrangian, right, that's going to be consistent with that principle in these limits, in the relevant limits. So it seems like the problems for the kind of canonical Humean account are caused by logical mathematical constraints on particles, laws, and properties, at least conceived of as quantum theory presents them. The observed states of Hermitian operators and so on. However, here's the kicker. Logical mathematical necessities are usually regarded as kosher for Humeans. Humeans don't worry about mathematical necessity, they're fine with that. Humeans don't worry about logical necessity, they worry about natural necessities. Okay? So can't then we be Humeans and necessitarians? Right? If it's mathematics that's doing all the work for you, why can't you still be Humean and say, yeah, but I think the laws are necessary? I think it's worth talking a bit about. It's worth thinking about anyway. So this Humeanism we've arrived at is clearly extremely dissimilar to the canonical version. No categorical properties, laws aren't contingent. But nevertheless, I didn't think that I had to posit any primitive necessity, natural necessity, in order to reach these conclusions about necessitarianism. Okay, so just a last thing before I think about some objections very quickly. I just want to say that this idea that these ideas that we're contemplating just now really comports with the hunches of a lot of contemporary physicists. So there's this quite kind of Leibnizian kind of spirit, it seems, in the high energy physics community, well maybe not so much now, everybody just seems a bit depressed, but maybe in the 90s or the kind of 2000s, there was this idea that you know, if you can find one consistent description of nature, right, you're done. It's so hard to satisfy all the constraints, all the requirements that we place on a fundamental theory or a theory of everything, that if you can find one way of solving this problem, you are done. Okay, so just to take a couple of quotes. So Weinberg, in his propaganda piece of 1992, Dreams of a Final Theory, says that, you know, he's talking about how there's a feeling of inevitability, right, about the laws of nature, right? To modify the laws without destroying the whole structure seems to be impossible, right? You can't fiddle with it without the whole thing completely falling apart. Einstein, at various points in his life, expressed the same view. Right, I would like to state a theorem which at present cannot be based on anything more than upon a faith in the simplicity, i.e. intelligibility of nature, right, nothing in other words. Nature is so constituted that it is possible logically to lay down such strongly determined laws that within these laws only rationally determined constants occur, not constants therefore whose numerical value could be changed without destroying the theory. Right? That's even saying that, you know, the laws of nature could be determined even up to a determination of the constants of nature. Right? Which is, you know, lots of people, even within high energy physicists, think, you know, if anything's the sort of thing that is just like a brute fact that one has to simply measure, it's got to be there. Not everybody feels that. Okay, so that's presumably, right, this idea that actually these constraints are so strong, there's only one way for a given set of fields to behave, something I've argued for, it kind of comports with these hunches of physicists, which is presumably, you know, a good thing. Okay, so this is going to go back to your point. Sebastian, is it? Yeah. that there's something question-begging about all this, right? I'm assuming things like the laws of quantum field theory. I'm assuming in any world in which there's quantum fields, they have to, have a unitary evolution and all that sort of stuff. Well, if this is question-begging, it's not entirely clear to me that it's question-begging, because what was what we were asked to think about in this debate between Humeans and anti-Humeans is debates over the interpretation of laws of nature. Laws of nature are things that occur within the framework. Coulomb's law is a law that occurs within a classical framework, right? QCD is a law that occurs within a quantum field theoretic framework. All I'm assuming is a framework. I'm not assuming like it's stuff about laws. The thing that I'm taking as primitive is the framework in which these laws are being formulated. So it seems that I'm being asked to take something else as primitive, right? Other than things, other than the laws directly. So it's not so clear that it's question begging. Still, you might say, well, it's an aspect. You're assuming an aspect of that which cannot be taken for granted, namely that these laws have a certain kind of structure, namely that they have that the evolution described in them is unitary and so on and so forth. Well, again, what I'm going to say is, when we're asked to kind of contemplate humanism by sort of recombinatorial principles, I would like to know in the first instance, what am I being asked to recombine? Am I being asked to recombine classical particles, or am I being asked to recombine quantum fields? These are really different things. I don't know what I'm being asked to recombine until you tell me what sorts of things I'm being asked to recombine. And when you tell me that, as I say, we're interested in quantum fields, we know that the reality is fundamentally quantum mechanical and relativistic, so could you recombine things like that? So you're giving me things that have certain properties, certain metaphysically interesting properties, like quantum fields are maximally entangled. They have this really holistic structure. They have, one might say, what's a quantum field? Well, it's an algebra of operators defined at every point in space-time. What other sort of metaphysically interesting things can we say about them? Anyway, you're going to give me a bunch of, as a metaphysician, I want to give me some metaphysical characterization of what it is that I'm working with. If you say, well, things with these features, they could occur in laws with a radically different framework, even though I used the superposition principle and I used the unitarity principle in my derivation of the fact that they are holistic, the fact that they are an algebra of operators at every point in space and time. Even though I use those principles to kind of define this thing, you then say, this could act in accordance with laws that don't respect those constraints at all. The onus is on you to show me that that's the case, because I think it's really unlikely that that would succeed. Okay, so that's what I'm gonna just put the ball back in the Humeans' court. I know that things with these metaphysical features, things that are going to be used to identify the sort of thing that I'm recombining to me. I know that these respect laws with these principles, and I know that because I use those principles to define to derive these metaphysical features. The onus is on you to show me that things with these metaphysical features can accord with a completely different framework. Okay, yeah.
So Lewis doesn't believe in trans-world identity. Right?
Yeah.
So what's at the heart of your question has to do with
duplication.
Which thing in this other world is to be.
Yeah.
Presumably they're not going to be counterparts either, because they're going to be so different. I can't remember what was the phrase he used in the quotation about how you were supposed to be sort of
patching together duplicates.
But wasn't there something about which one is? Okay. Oh, right. I see. So duplicates of things.
Yeah.
So that just seems sort of. Is that just stipulative then? I'm just going to say that's the duplicate.
Well, you can't do that. I can't say this is the duplicate of that. I can't do that. Right? There has to be some objective similarities between them in order that I'm going to, So we have to say, for this to be like a classical particle can be a duplicate of a quantum field. I mean, the problem with, yes, if that's where we want to go. Anyway, my point is I'm putting the ball back in the Humeans' court.
Yeah.
Right? Yeah.
I'm just wondering, could you maybe say a little bit more about, I'm just thinking of unitary as a specific example of something that might be wrapped up in what we're assuming in the framework of our model of quantum fields. So I don't know much about quantum field theory, but I know like in non-relativistic quantum mechanics, you can have a very sensible quantum system that, because it's interacting with its environment, it doesn't evolve unitarily. Now, as a matter of fact, in our world, to the extent we're modeling just normal quantum mechanics, we think that it does everything well as materially. But I can very easily imagine a world where the fundamental dynamics was non-unitary, but still sensible in some way. And I'm just wondering,
Sure.
is there like a similar thing?
No, I'm sure one can write down all sorts of well-defined, mathematically well-defined worlds that don't have unitary evolution. What I'm questioning is whether these can be worlds that contain duplicates of parts at the fundamental level.
So he's probably thinking these things still have color and flavor, but they don't have labels. It's great that he picked that particular for you. It's great that he picked that particular example, isn't it?
Yeah. Yeah, it's a bummer because people like David Lewis was a genius in that lots of his philosophy is actually informed by very good science, just not at the most fundamental juncture, like where he really needs it. Like people's a little
right.
Yeah.
I was just wondering about, what is it you need to add to humanism? This is what you said, if it's a necessary feature of it. I was just wondering, isn't a better way to characterize it in terms of essentialism? That, it's essential to being a quark color that you feature in
Yeah,
the
so I think,
So that would definitely depart from Lewis, but you're not necessarily talking about essentialism. You say what it is to imagine a world in which there are quark colors is for these structural aspects to the
yeah, in the same way that what it is to imagine a world with mass is for there to be properties that are parts of this thing that has a certain mathematical structure. So essential is the right word. We'll talk about that in a. So again, Lewis is going to deny that they're necessary as much as he's going to deny that they're essential. It's just that essential has more sort of baggage associated with it. People don't really want to say that. But what do you mean is essential? So this is featured in the next argument as well. So if you're it seems that a better word to say is it's essential to color that it transforms according to SU3. That's better than saying necessary, because lots of things are necessarily true of the SU3 group that aren't essential to it. Like it's necessarily true of the SU3 group that 2 + 2 = 4. But it doesn't have anything to do with it, it's just necessarily true of it. Whereas essential facts are things that kind of get to the natures of things, their intrinsic features. So yeah, that would be a better way.
I was going to say maybe intrinsicness is another illuminating way to think about this. If you're supposed to imagine sort of taking a thing and then a qualitative duplicate of that thing, what matters is maybe even not so much what's essential to the thing, but what you cannot help but take along with the thing when you duplicate the thing.
Interesting what to when you put it like that, what the relationship between essential and intrinsic is. There can be intrinsic properties of things that are not essential to it. But this you really want to say, actually, it's got to be essential to it as well. Anyway, so that's basically, I think, where. And the other thing, let me say 2 more things. This is basically what I'm saying with this kind of last objection is that, if I'm going to do metaphysics of physics, it seems like I have to, or you're going to do metaphysics, you have to assume some kind of framework. Somebody has to take certain stuff as primitive. Right, so this is a nice paper by Fraser McBride, fellow Glaswegian, called Can the Property Boom Last? Which actually has nothing to do with the content of the paper, but he talks about, so it's all about the metaphysics of properties, and basically he says that, in thinking that Lewis has actually provided us with an analysis of metaphysical necessity, is a bit of a fantasy, because in order for him to set up his system, he has to make certain postulates, right? So when I'm recombining properties, right, the idea is that there's all these unary properties, there's all these binary properties, i.e. relations, tertiary, right, 3-place relations, and so on. We've got lists of all the fundamental natural properties, right, and their arities. And when I'm recombining properties, it's like Carol Vorderman, isn't it? Where you just sort of take one down from each, and you swap them around, but you can only take a one-place property and replace it with another one-place property. And any relation you have to pick another perfectly natural relation. It's like, why? Why can't a 2-place property be a 1-place property in another possible world? And you might say, it's just, that doesn't make any sense. It's of the nature of properties, boom, and then you're dead. Right? You've stipulated something that holds in properties in any possible world. Lewis has to postulate logical facts about properties that hold in any possible world. I'm positing one too. What are the rules of the game? Whereas his posits are fine and mine aren't. No, anyway. So paradoxically, look, what are the rules of the game here? Some of you who don't have a kind of weird relationship with metaphysics, you sit in the metaphysics room and it's like nobody explained the rules of the game to you. I'm really interested in the rules of the games, and I think that they have to be made more explicit than they are, right? One final thing that I'm going to say about this. This is going to connect with, I think, what we're going to connect with the next topic. Let me just say this. So it just seems that yes, it will connect with the next topic. There's this big sort of disconnect between analytic metaphysicians, especially the Humean variety, and philosophers and physicists, right? So this is something we saw a bit yesterday, just in the kind of conversation. Humean metaphysicists see all this freedom in the world, where physicists see constraint and determination, and it can't be other than, it can't be otherwise, right? Do you have any idea how hard it is to just write down a law that deserves to be called fundamental? Do you have any sense of how hard that is? And if you did, maybe you would realize that if you can find a solution, the idea that there could be 100 other solutions is like, show me. The burden of proof is very much on you to show this. Where did this disconnect come from? I think it came from the positivists and they gave us, like I said, this make work project of taking mathematical theories and then sort of writing them out as bits of predicate logic. It's really easy to write down a well-formed formula of the predicate logic. It's really easy. You can get like first year, like undergraduate students to write down well-formed and get like tick. It's really easy thing to do. It is not easy to write down functions that stay well behaved in limits. And that's how physicists think about fundamental theories, right? We've forgotten, I completely get that apparently you can model all of mathematics and set theory, including stuff about limits, and you can model set theory in terms of predicate and so on and so forth. Or you can express set theory in terms of predicates and so on and so forth. The point is, when philosophers write down little Ramsey sentences that they're going to use to express recombination and so on, they're not bothering to think that are these models of the are these models of the real numbers, right? Very, very hard to find statements that really are well defined in these limits. So that's where the problem comes from. It's our fault as philosophers of science. Anyway, that's just a hypothesis. Yeah.
I want to put a figure on that. This is what Mark Lawson calls theory T syndrome.
Aye.
That infected a whole bunch of analytic philosophers in the 20th century.
Yeah, there's another, I need to get that. There's a paper by, can I write on this?
No, this one.
This one.
Around this one.
Yeah, there's this lovely paper by Barry Stroud called Against Fantology. So fantology is the theory of, the fantastical, but he writes it like this, of course. So yeah, he just thinks that this, just expressing everything, theory T syndrome, just creates, it's the point made by Bertrand Russell and so on, that natural language creates these illusions of how things have to be, right, when they don't have to be that way. And I think this is potentially just another instance of that. Okay.
Can I
yes, of course.
make a different speak for the Humean a little?
No. Well, okay, go for it. It might be good. Yeah.
So, why wouldn't the Humeans' reaction to this just be to say that that quarks, and let's leave aside how I'm getting to refer to quarks, but I suppose I picked them out in this world. It's just a law that they have color in the sense that the SU2. But it's just a law like any other Humean law. It's part of the simplest, strongest, best system for the current facts of the world. So there's no new necessity here. The analysis is great. I love but what it's pointing out is that there's more laws than we kind of thought that there were, and some things that we didn't sort of. And if you don't want to call it a law because you think law has to sort of correspond to use a bit better, then okay, all right. But there's a necessity in there, but it's a natural necessity that's just going to have the same Humean analysis as any other one. It's just supervenient on the current facts.
But again, these claims are sort of expressed in terms of what you can do with duplicates. No? That if these quarks could have behaved, like the way you're going to express that this is just part of the best system, or you could take these things and put them in another world where there'll be another best system. How is this different from just saying that this relationship
Well, that would be a
between
physically
colour
impossible world, right? I mean, because it's a law that they said that quarks have color. You know, I'm not a modal realist about Lewis, so I'm not really worried about other facts about what's happening in the world. I can kind of set down some laws and then rules and then construct abstract worlds as I like. But I'm interested just in getting understanding the necessity that's here as a kind of natural necessity, and obviously one of the rules of the game is once you've in the best system picture, right? So once you've developed the best system, and you say, well, I'm just going to kind of allow myself all logically possible worlds, but there's a subset of, proper subset of those are the ones that actually, in which the laws are, those laws are true, and those are the ones that I'm kind of interested in when I'm playing this kind of modal game.
So I think, we're talking about natural necessity, so this is tends to be, so you're saying, so this tends to be articulated in terms of where the law's being held fixed, and we also I'm saying there's got to be, I'm thinking about a kind of framework necessity, right? What are laws, how is it possible for quantum fields to behave, right? But you're going to say that's also just a kind of natural necessity.
So what you were calling the framework, I think that's right. I mean, why not, first order, just call that laws as well, but if you want to make some other, I can see one might want to make, would probably want to make some other distinctions, but there's just natural necessity there, and it's of the supervenient kind that the Humean has already.
So I think I'd just say the same thing that I said. I think this is just Sebastian's point, and then we just reply to it in the same way. But that's just contingent. Any relation between colour and SU3 is just contingent. That's what he said. That seems to be what you're saying.
No, I don't.
You don't think so?
That wasn't quite the way I was.
No.
I mean, the way I said it was that quarks have color, and color has this. I just mean by the color, that they have this property that has the SU3 representation of SU3 structure. Or I can just drop the word color if you like. And just go straight to the SU3. So, right. So maybe you want to so then maybe to make the same point then is to say, but I'm now leaving it open that it's in a broader sense contingent that quarks have.
I think also, when you say we need to call it colour,
but again, then
because we're talking about how colour can behave in other possible worlds. So we need to be talking about the same thing, and the question is how much do we have to pack in to be talking about the same thing, right? And I think this is something, clearly this is just a point between which Humeans and anti-Humeans are just going to diverge. That's just part of the package that the anti-Humean pack sort of more in. But what I say is that the Humeans, at least historically looking at it, have been happy to pack in mathematical facts as part of what you mean about the same thing. Like Armstrong, it has the same mathematical structure associated with it, but it can enter into different laws. The dispositional essentialists will say, no, it has to enter into the same laws. So I'm trying to sort of... Yeah?
I mean, I think I just have a very different kind of picture of how rules, what the significance of rules about possible worlds.
Yeah.
So one of the challenges, right, was just to understand the natural necessity, and that's, I think, identifying this class. I mean, it's the class of possible worlds, which are the ones in which the rules are true. But I'm not. But if you're not a modal realist and you think the worlds are just ersatz, then you have this kind of way. I guess you want to be constrained by logic, but okay. Other than that, there's a way. What kind of facts are going to constrain how you do it? In principle, as long as you specify what you're doing with the possible worlds and had some rules that seem that you could argue would help you do it, you could play with whatever rules you wanted. I mean, what the rules normally are, I think, are just facts about linguistic use. They're sort of facts of experimental linguistics, something like that, about what counts as possible. Right. So okay.
I need to I'll follow up.
That's but I take it Lewis thinks I think you're absolutely must be right about Lewis that the rules he's putting down about how possible worlds behave and relate he has a very different picture about that. Those are kind of metaphysical facts.
Yeah.
And I totally agree. Like, where are they coming from? And
Yeah. So I'd be interested to hear how, if it's kind of like linguistic usage. I mean, it's physicists who talk about color, and that usage is completely replete. I mean, it just is mathematical chat, most of it. So I'd be interested in how that makes these things.
But yeah. So then scientists play the games where they want to sort of use dispositional talk and sort of nomic talk for the Humean and with sort of best system analysis. Somehow that all has to be kind of elliptical for talk about the occurrent facts, and so the story is about how to unpack that. And that's why the linguistics comes in, I think, because you want to know what they're trying to do with it. And yeah.
Can I maybe move? Yeah, just. Is that okay? So I do want to, this is pretty similar, like, it's not a million miles away, so I bet we could continue a lot of the same. Yeah. Okay. So, I just presented how, and of course, so lots and lots of objections, but hopefully, more than anything, I'm interested in getting at these rules of the game, right? And articulating what they are. And I think that there's some really interesting resources in fundamentality considerations in quantum field theory for kind of making us either realize some hitherto sort of unacknowledged possibilities, or making us think harder about what it is we're doing when we're doing modern metaphysics. So the other thing that I want you to sort of talk about, so to use these constraints, the same stuff that we've already been through, the constraints on fundamental theory, is to do more kind of interesting metaphysical work. And the other thing that I'm going to use it to do is to sort of challenge how it is that metaphysicians think about what it is to be fundamental. Now, this is going to be a talk that's aimed more, I suppose, at metaphysicians. It's kind of insider baseball, and I'll try and get people to care about it. So I think everybody's going to care about the issue, but, and I have to say, like, the argument that I'm going to give you, that there's something that we can use, these facts about quantum field theory that we can use to challenge these metaphysical presumptions. I think, in fact, I thought until yesterday when we had a discussion group, I thought this argument has got to be wrong. But now I'm actually not so sure. So I thought it was wrong, but probably instructive. Like, even if this is not how to think about it, the issue of explaining the fundamental, right, there's something to be learned in this process. And I'll talk a bit more about that at the end. So, in some ways, this is going to be this idea that we can use physics to challenge our ideas about what it is to be fundamental is in some ways more radical from a certain point of view than saying that we can use physics to challenge our ideas about whether modality is fundamental or something like that. Because people the kind of received view of the kind of autonomy of metaphysics is that it's metaphysicians' job to tell us about the fundamental metaphysical categories, like what an object is, what a substance is, what I guess space and time, people would be a bit hedgy about that, even armchair metaphysicians. What a person is, what modality is, and so on, what truth is. And then once we've decided on the intention of these terms, what they mean, then it's fine to say to physicists, all right, what are the fundamental properties, what are the fundamental objects, what are the fundamental laws, this, that, the other. Or maybe even something like, is modality fundamental, but you're going to tell us what it is for something, what modality is in the first place. Here, I'm sort of being a bit more radical in that I'm not just using physics to tell us maybe interesting things about, or new and unrealized, unacknowledged hitherto possibilities about what is, as a matter of fact, fundamental, the extension of the term, but actually use physics to change the intention, right? What it means for something to be fundamental in the first place. The right question, let's hold on. And so the metaphysical view that I'm going to challenge here is the view of the fundamental, according to which what it is to be fundamental is to have no explanation, right? So what it is to be fundamental, in other words, is to just be brute, just be a brute, inexplicable fact. Okay, so here's some quotes from the kind of recent read metaphysics literature. A fact is fundamental or brute, if and only if it does not obtain in virtue of other facts. Ross Cameron, the fundamental or brute truths, if such there be, give us the ultimate foundation for the whole of reality. Fundamental or brute facts must be facts within physics, or micropsychism would need to posit fundamental or brute laws, right? So, all these claims are perfectly unremarkable, because the literature is just peppered with claims like these. All of these are claims in which the word fundamental and the word brute are just taken as just obviously synonyms. Like the word brute just saves you, but it's a bit more economical. They just mean the same thing. To be brute, to have no explanation, that's just the same thing as what it is to be fundamental. So call this view of the fundamental that's presupposed here, we can call it brute fundamentalism or brutalism, right? To be fundamental is to just be brute and inexplicable. That's brutalism. Okay, now what got me thinking about this issue, and this kind of relates to what I was just saying about this kind of Leibnizian sort of kind of frame of mind that seems to be afoot in contemporary physics, high energy physics. This view of what it is to be fundamental seems increasingly out of step with the way that physicists sort of think about it. Because as I'm sure you know, physicists have repeatedly sort of mooted the idea that maybe, you know, with a theory of quantum gravity, we might be able to explain everything, right? Including the fundamental. We literally have a theory of everything, and since everything includes what's fundamental, we have a theory of that too, an explanation of that too. So here's a couple of quotes. Stephen Weinberg again. The aim of physics at its most fundamental level is not to describe the world, but to explain why it is the way that it is. Right, that's a bit awkwardly expressed, but I take that to mean, partly from the context, right, that really the aim of physics, the ultimate aim of physics, is to explain even the fundamental level. Right? Fundamental physics doesn't describe anything that's not fundamental, that's not the aim, so why even bother saying this if you're not saying it's our aim even to explain the fundamental. Here it is more explicitly in Brian Greene's popular Bricon string theory. For the first time in history, we therefore have a framework with the capacity to explain every fundamental feature upon which the universe is constructed. Again, a bit awkward, but I take it that's what he's saying. So, there's a kind of, as a metaphysician here, you reach a bit of a choice point, right? This time, can we explain the fundamental? Right, what are you going to say in the face of this? Is this just incoherent? It's like, this doesn't make any sense. It's like saying, oh, I want to be a bachelor with 10 wives. It's like, it doesn't, that's not a coherent notion. Or, on the other hand, is this a kind of just another kind of instance of the kind of phenomenon that Quine, you know, made famous, according to which there's no analytic truth that is immune to revision in the face of experience, right? This is a kind of choice point. And so, what I'm going to argue is that there's a very natural sense in which we have to give up, right? If you take quantum field theory seriously, you have to give up this kind of received metaphysical view. And it's a kind of brute force argument that I'm going to give, no pun intended, but hopefully we'll have time to talk about it in the problems of it as well. But anyway, just a couple of reasons why you might want to worry about this issue. As a metaphysician, you might worry about it because you might worry because virtually most metaphysicians are physicalists about the actual world, right? They think the fundamental stuff is physical, and these questions about how contentful that assertions like that are. Do you not run into discussions about why it's unclear what the content of claims like that is, the reality is ultimately physical? I recommend Van Frassen's The Empirical Stance. I think it's chapter 2, where he talks about how little cognitive content there is associated with these claims. But that said, most metaphysicians are physicalists about the actual world, right? I.e. believe that the fundamental properties and facts are physical, and everything else obtains in virtue of them. So if it turns out that the physicists think that these fundamental facts are explained, like, what position are you in to argue with them? As a philosopher of science, you might want to be interested in this, even if you don't care about metaphysics. Just because I think we often think of your business as a philosopher of physics is just to interpret physical theories. It's not. Your business as a philosopher of science is to understand scientific discourse in general, at least I think, or at least that's our project in philosophy of science. What are the aspirations? What drives physicists? Do those aspirations make sense? Their popular discourse can be very revealing, right? You know, these are all bits of discourse we want to understand instead of just picking apart theories. Okay, so what I'm going to do is think about what, if first of all, it's not obvious what these claims mean. And again, these are propaganda pieces. Propaganda pieces by people that are probably a bit paranoid that they don't have any empirical evidence anymore, right? So, can we make sense of this, right? What would it mean to explain the fundamental? And I'm going to do it by sort of brute force translating this talk into familiar idioms of explanation from philosophy of science and from metaphysics. So there's a question about whether this is the right way to proceed. Okay, it might be that explaining the fundamental is just such a weird concept that this is not the right way to do it. The only other place, or another place where I've seen, well, the only other place where I've seen, and I don't very widely to be completely honest with you, somebody proposed a theory of what it means to explain the fundamental is, I think, chapter 3 of Nozick's book, Explanations, which is really brilliant. He tries to model what it would mean to explain the fundamental by making this analogy with the liar paradox and non-well-founded set theory, where you get sentences talking about themselves. It's really weird. Probably doesn't work in this context, but it maybe is. The weirdness is maybe appropriate to just like the very weirdness of the concept, right? So I'll ask you to consider whether I've got about things in the right way. So what I'm going to argue, after looking at the existing literature, is that it's not the case that the fundamental establishes no explanation, because we can give a partial explanation, right, which is a term from Karl Hempel, of a fundamental fact, namely what the actual fundamental counts are, and hence it's just false that no explanation can be given to the fundamental. It seems some explanation can be given to the fundamental, right? And then we can think about how this would extend to maybe, giving total explanations of the fundamental. So the structure is going to be pretty straightforward. I'm going to argue, or I'm going to claim, what fundamental kinds the world exhibits is a fundamental fact about the world, or a fundamental feature of the world. I'm going to be very sloppy about the distinction between facts and features. Consistency considerations in quantum field theory entail that these kinds are significantly constrained. This is something we already saw. This is just the Goldilocks principle. Premise 3, these constraints result in an account of the fundamental kinds that has the form of a partial explanation in Hempel's sense. Right, together with the assumption that this constraint follows from the essential nature of quantum fields, which is an assumption I'm now going to be very explicit about because it's expedient for me to do so, we can regard this account as a genuine explanation, moreover a genuine metaphysical explanation. And I'll talk about what the significance of that is in a minute. Okay, so this issue, what I'm going to talk about, hopefully, do I have a bit of extra time, right?
Yeah, we started 10 or 15 minutes late.
Okay, great, I should be able to get through this. It's pretty simple. All the hard work is really been done, pretty much. So there's going to be clear connections between this stuff about explanation and the modal stuff we've talked about already. So here's this is why this is so communicated by Hugh Mellor, not David Mellor. He was a Tory MP.
Yeah.
Hugh Mellor. Right. He says back in 1976, one of the early papers on probabilistic explanation, he says, "We call for explanation only of what, although we know it is so, might have been otherwise for all else of some suitable sort that we know." Right? We call for an explanation when there is a gap between knowledge of what is and what must be. Okay. So, like with everything to do with explanation, what that means is kind of ambiguous. When you think about how it relates to the physics. So, when physicists say, actually, I forgot I can't quite remember what I was going to say here, so I'm a bit subtle. I'm just going to, given that we're a little short of time, I'm going to leave it. Maybe I'll come back to it. What's going on? Forget it. Hopefully I'll come back to it. Okay, so anyway, in embedded, it's pretty clear from that these clear connections between explanation and modality. You only ask for an explanation of something when you think that it could have been otherwise. Now, physicists think the laws of nature. Yeah, maybe that's the ambiguity. Physicists think that the laws of nature. There's a hunch that the hunch that we got at last time. Physicists think that the laws of nature maybe couldn't be otherwise. Okay, so do they say? So this is kind of Leibnizian hunch. The laws of nature couldn't be otherwise. There's also this hunch that we can explain everything. So in saying that the laws of nature couldn't be otherwise, are they saying, given that we call for explanation, only of what, even though we know it is so, might have been otherwise for all else of some suitable sort that we know. Given that they think the laws of nature couldn't be otherwise, does that mean that they think there's no explanation to be given of these things, right? There's no gap between knowledge and what is and what must be? Or is it that they think that we needn't call for explanation there because in showing that the laws of nature are necessary, we've actually shown that we're able to explain them? Right? Are we not calling because would we not be calling for explanation because we think we already have the explanation, so we don't need to ask for it? Or are we not calling for it because we think they're fundamental and hence not the sort of thing that we need to explain? Anyway, that wasn't a point well made, but there's certainly connections here anyway. Now, in making this argument, as I say, it's going to be crucial. This claim, I've already flagged it up. I'm going to assume that quantum fields are essentially such as to evolve unitarily. That's going to be essential to my argument. Now, this is a fundamental fact, presumably also one that is going to be unpalatable to humans, right? We've been arguing about. Neither of these facts really worry me. That I have to assume something fundamental to explain something else fundamental is fine, because I'm not arguing here that everything fundamental can be explained. I'm arguing that there's some fundamental features that we can explain in some measure. That is enough, as I understand it, to falsify pluralism. As to the stuff about Humeans, that it's not palatable to be Humeans, I think this issue that to be fundamental is to be without explanation is one that is accepted by metaphysicians in general, whether a Humean or not. Right, so hopefully it's of interest even to Humeans, even if they disagree with some of the premises, rightly or wrongly. More worrying to me about this argument, and at least this made me think this showed that the argument was wrong until we had this conversation yesterday and I realized something. What worries me more is how this proof that the fundamental can be explained is going to operate in the limit of total explanation, right? So what I'm going to argue is that we can give a partial explanation of some fundamental features, namely the fundamental kinds. There's a certain way of understanding the fundamental, namely if we do it in terms of grounding, which I'll talk about a little bit, that suggests that if we were to promote that partial explanation to a total explanation, we'd be in a position to say that you've explained is not actually fundamental. We'll see that. So that seems like a real problem. Like the better the explanation gets, the less likely it is that it's an explanation of the fundamental in some sense. But I actually think these ways of understanding the fundamental that don't have that consequence. Right? It's a bit abstract. Hopefully you'll have a better sense of what I mean by the end. Okay. So first of all, let's think about again the core commitments of brutalism. Right? According to brutalism, that which is fundamental is that which is root. Right? That which is, we saw people use these two terms as synonyms. Metaphysicians use these two terms as synonyms, right? They have the same intention to mean the same thing. What do metaphysicians mean by brute facts? Here's a representative sample. They're facts that have no explanation, that for which is no further reason or explanation, those which occur for no reason whatsoever. They have no explanation of any kind, for which we can just suddenly say, there's no reason. They're arbitrary, no rhyme or reason, no explanation, for which there's absolutely no reason in the nature of things as to why it exists or is the way that it is. Right? This is how I'm going to understand brute. To be brute is to have no explanation whatsoever. Right? So, if I can show that there's a partial explanation, you can sort of explain them, that's going to be, right, that's going to be a problem for brutalism. Now, not everybody understands brutalism in this, to be brute in this way. Some people say that they can't be completely explained. That would be untouched by my argument. But this is what metaphysicians seem to have in mind 90% of the time. Okay, so brutalism I'm going to take to be the thesis that every feature of the fundamental level is wholly lacking in explanation. Now, this idea of the fundamental gets support from the contemporary literature on grounding. So if you are not familiar with this, again, this is something, this is a term of art for metaphysics that you just sort of learn by osmosis, sitting about in metaphysics rooms. It's very hard to say what it means. But roughly speaking, it's the level connector, it's the relationship that exists between the fundamental and the non-fundamental that makes the non-fundamental non-fundamental. It's grounded in the fundamental. It's that which organizes the world into a tree-like structure of fundamentality. Hopefully that's clear. Now, this is sometimes, this notion of grounding, this relation between the fundamental and the non-fundamental, the metaphysical relation par excellence, is sometimes used to define the fundamental by people like Jonathan Schaffer. Right? To be fundamental is to be such that nothing grounds it. Right? You ground everything else, nothing grounds you. Okay. So what do we know about this relation? Well, not a lot. We know that it's more discriminating than supervenience. That's the one bit that pretty much everybody agrees on, right? So it's stronger than mere logical or modal correlation. It's an explanatory relation of some sort, right? But that which grounds everything else should sort of explain why this thing, that other stuff exists. Okay, so it's not just a form of explanation. It doesn't just have an explanatory sort of character. Metaphysicians increasingly see grounding just as the relation of metaphysical explanation. These two things are the same things, right? Here's some quotes to that effect. I take grounding to be metaphysical explanation. To say that phi grounds psi is to say that phi provides a metaphysical explanation of psi, right? These mean the same things, right? Again, examples of people using the word metaphysical explanation and grounding as just synonymous, right? Grounding relations stand to philosophy as cause stands to science, right? Just science looks for causal relations, metaphysicians look for grounding relations, right? Metaphysical explanation is just grounding. A bunch of other quotes I can throw at you, but hopefully that suffices to make the point. So then, if we now analyse to be being fundamental in terms of not being grounded, that lends support to brutalism, right? Because it just means you're not explained. You have no explanation. Nothing grounds you. You have no metaphysical explanation. Okay. So. Next point, next premise. What are the fundamental facts about the world? Well, I'm going to take one obvious fundamental fact about the world to be the fundamental kinds that it instantiates. So again, this is more sort of addressed, so hopefully that just has some independent plausibility. For those of you who are more familiar with the metaphysics literature, we can note that people like Ted Sider. So Ted Sider rejects this idea that you should analyse fundamentality in terms of grounding, for various reasons. He thinks that the notion of fundamentality should be replaced by, or is analysed by a notion of primitive structure. Right, the world has a primitive fundamental structure, and that he describes in terms of carving at the joints, and to be fundamental is just to be something that carves at the joint somehow, right? So again, this is just like another metaphor that he tries to elucidate in his extremely confusing book. But it's not, so he tries to argue for some really weird stuff in that book, that like quantifiers carve at the joints, and like, right, what do you mean by carving at the joints? Well, there's one thing that he's like, it's just like the way that electrons carve at the joints, right? You take all the things in the world, these better ways of grouping them, and the best way to group them, the best joints to carve are between the fundamental kinds. Like those are the kind of joints in nature everybody understands and can agree with. I think quantifiers are just like that. Now lots of people attack that quantifiers are just like that. But everybody seems to get the idea that, yeah, if anything carves at the joints, it's like things like electrons, i.e. it's the natural kinds. That's the kind of thing that counts as a fundamental fact about the world. What the fundamental kinds are. Everybody seems in agreement with that. So putting all this together, I would say that we can write down this thesis, brutalism of fundamental kinds, and that most metaphysicians will agree with this. So suppose that the fundamental kinds, so actually, let me put it this way. Right, suppose that of the fundamental kinds, right, suppose that there's just a bunch of, and actually if you believe in dualities, you're not going to want to put it this way, but this went through peer review by a bunch of metaphysicians who maybe rewrite it and maybe they preferred it. This is how they preferred it to be written. Right, suppose that of the fundamental kinds, those instantiated in the world are kind 1 to kind p. Let these, so maybe, it's electrons, positrons, the Higgs boson, whatever. Let these kinds be collectively denoted Fk. Then that the fundamental kinds that are instantiated in the world are these kinds is a fact for which no metaphysical explanation can be given. Right, putting brutalism together with the idea that fundamental kinds are, what the fundamental kinds are is a fundamental fact about the world, most people are going to be committed to that. Okay, now I'm going to take it as a datum going forward that we do not yet have a fundamental theory, and as such I'm not in a position to say what this set is. Right, we just don't know exactly what the set is. We only know about the most fundamental kinds so far discovered. Okay, nobody claims that this is the last word on what the fundamental kinds are. However, you might already be suspicious of brutalism just on the basis of the physics that we have done. for many of these kinds that are, you know, the kinds of the standard model, the most fundamental kinds that we've managed to kind of conjure up, many of these were predicted in advance, right? The Higgs boson just being the last of these, the most recent. And given, right, again, if you're familiar with like things like Hempel's model, which is old and staid, but still really structures this conversation about scientific and metaphysical explanation to an enormous degree, of the intimate connections that exist between prediction and explanation, right, both are kind of relations of derivation, you might think that the fact that we've been able to predict these kinds in advance suggests that there's reason to think that we have an explanation of these kinds, right, or at least we're in a position to explain, from the fact we predicted things like the Higgs boson, we're in a position to at least try to argue that we could give some explanation of the Higgs boson's existence. And for all we know, maybe the Higgs is fundamental, right? Maybe that will feature in the most fundamental kinds. We've got reason to be suspicious of brutalism. However, it seems to me that as long,
Yeah, I have a question about this fundamental kind of stuff we're discovering. Is it possible that when physicists are talking about explaining the fundamental, that they're talking about pushing back what's fundamental, or kind of discovering, you know, the things that are fundamental now aren't, and other things are fundamental, whether there's like an implicit now when they say fundamental?
No, I don't think so. Like, so there's quotes from like Brian Greene really are in the context of a final theory. When we have that final theory, we'll have an explanation of everything. It's not like this infinite regress that will always be able to explain what was thought to be fundamental, right? Otherwise, they wouldn't be advertising this possibility of a final theory. Yeah. There are, of course, physicists who do believe, and philosophers of science who do believe in this kind of infinite regress model of reality, because they think it's actually just scientifically very fertile and beautiful, whatever reasons one has to believe in such things. I can give you some references on that. David Bohm was one. So you might think, given that we've been able to predict some of the particles in the standard model, that makes us suspicious that to be a fundamental kind is to be the sort of thing you can't explain. However, so long as we don't have a fundamental theory, it seems to me that brutalists are free to deny the significance of any such successful predictions that we've made in the past, right? As long as you're free to say, you don't know that that kind is fundamental. Even if you think, that there's some intimate connection between prediction and explanation, this doesn't worry my thesis. Because if you're a brutalist, you just think that there's this fundamental metaphysical distinction between non-fundamental stuff and fundamental stuff with regard to explanation. So even if you've managed to explain the existence of some kinds already, so long as you're in a position to say, well, yeah, but that kind may not be fundamental, then they're willing to say, well, I don't think that you can make any inductions on the basis of what you've managed to do in the past about what it is to be fundamental, because it's just a fundamental disanalogy between the fundamental and the non-fundamental stuff with regard to explanation. Okay, so we can't make any inductions on the basis of our past successes to thinking brutalism is wrong. So it's hard to see, like, insofar as we don't yet know what the fundamental kinds are, like we don't in the present, how it is that we're going to argue for this thesis. So I say there's a workaround. For suppose you have some idea of the framework in which the fundamental kinds are correctly described. Okay, so this is something we've talked about. Natural kinds are things like electrons, positrons, photons. Framework kinds are things like classical particles, classical fields, wave functions, quantum fields, strings, and so on. So it seems that we can have a view on what the fundamental framework might be without knowing what the natural kinds are. And I would argue, and you would have seen, you can already have a sense of how this goes, by postulating that some framework kinds, are fundamental, that can help us explain the fundamental natural kinds, even if we don't actually know what they are yet. Okay, so we can be in a position to make this argument, even though we can, in the present, even though we don't know what the fundamental kinds are. Okay, so how is this going to work? Well, it's not that complicated really, given the work that we've done. So we're going to do like we did last time, situate ourselves in the framework of quantum field theory, which we know is not a truly fundamental framework, or at least we don't think that. We're going to think a little bit about how our conclusions might generalize to our more fundamental framework. So in taking the fundamental entities and fundamental kinds to be things that are to be quantum fields, we're assuming that they're the sort of thing that evolves unitarily, right? That's part of what it is to be a quantum field, right? According to most people. Now, so hence, I'm going to assume that the actual fundamental kinds are necessarily such to evolve unitarily. In any world, given that I'm doing metaphysics within this framework, any world that I contemplate within this framework is going to be a world in which fields are evolving unitarily, right? So they're necessarily such as to be evolving unitarily. But I'm going to go further, and I'm going to assume that they're not just necessarily this way, they're essentially this way. It's just part of what it is to be a quantum field, to undergo this kind of evolution. It's part of their nature to do that, right? So it's not necessarily true of them in a way that 2 + 2 = 4 is necessarily true of them. It's a fact that's intrinsic to them, however we want to put it, a fact about their nature. And I'm deliberately wrapping this up now in metaphysical language, because it's going to be helpful for me to do that. Okay. Now, something I'd like to ask you about this is, could we do without this? It'd be nice not to have to kind of engage in this kind of metaphysical language. Maybe when you're writing papers for metaphysicians, maybe not so much when you're speaking to philosophers of physics or physicists. There's also a worry about how this fits in with GRW, which I don't think is actually a worry, but I'm not going to go into that, even though that's not obvious why I don't think it's a worry. Okay, so what I'm going to argue is if you think the fundamental framework kinds are kinds of quantum fields, then you can have some explanation of why the natural kinds in the actual world are the kinds that they are. So how is this going to go? Well, we're going to exploit the same constraints on fundamental theories that we already derived in order to do this. So we already know, if we want to explain the fundamental within the context of quantum field theory, we're thinking about things that are described in the fundamental theories that quantum field theory permits. And these are theories that are operating under extremely tight constraints. This we know. Okay, so one thing we know about these constraints is that such theories, it's going to be a local gauge theory. This did a lot of work for us last time. The constraint that's going to do more work for us this time is the second one, right? The idea that you can't have too many fields in your theory if your theory is going to count as a fundamental one, right? So we said in the case of QCD, there was an upper limit on how many fields you can have in there. The upper limit is 16. Right? So a priori, you could have one quark evolving in QCD. There are one quark models of QCD. But you could, a priori, you could have 17, 18, 19, and so on ad infinitum. But it turns out, when you think hard about it, if this is a fundamental theory, you can. Okay, so this gives rise to, like I say, the Goldilocks principle of fundamental kinds. Whatever the set of fundamental kinds is going to take this form. There's going to definitely be some bosons in there, right? This comes from the local gauge thing. And there's an upper limit on how many fermions there are, and what these numbers are going to be related to one another, group theoretically. That bit we didn't talk about. Okay, now, like I said last time, we deduced this on the assumption that quantum field theory is a fundamental framework, which is probably wrong, and also that fundamental theories are not just asymptotically safe, i.e. well-behaved in limits, but moreover asymptotically free, which is a very special class of fundamental theories. Like I say, there's many more ways to stay finite than to tend to zero, so it really is a super special case. However, I would like to point out that there's now, people are kind of having more success in developing mathematical techniques that are beyond perturbation theory, that are used to investigate theories that are asymptotically safe without being asymptotically free. And so being able to sort of think about what constraints might be on fundamental quantum field theories more generally, and these are all pointing at the same sorts of results. Okay, so here's a paper by Astrid Eichhorn, who some of you might have heard of, Perimeter, Roberto Percacci, who's been one kind of on the front lines doing like scientific communication on asymptotically safe gravity, and this other individual that I don't know. So here's what they say. I'll just read out a little bit of this. A quantum theory of gravity that is a viable description of the microscopic degrees of our dynamics of our universe must include dynamical matter degrees of freedom. Nevertheless, matter is often ignored in quantum gravity or not included in a fully dynamical way. While this could result in a self-consistent quantum model of gravity, it's not clear whether it can yield a model of quantum gravity applicable to our universe. as in other settings, with the addition of further degrees of freedom, can fundamentally alter the character of the theory, dynamical matter might not be easily incorporated into a consistent microscopic description of gravity. As an example, consider Yang-Mills theory, which is ultraviolet complete due to asymptotic freedom. If too many fermions are present, asymptotic freedom is destroyed. A similar effect could occur in gravity, where too many fields, right, could preclude a particular scenario for UV completion, right? And so they talk about how, they mention how in gravity, the fixed point can't be the Gaussian fixed point, i.e. the theory won't be asymptotically free, so you have to look at where the coupling stays finite but not zero. And what they derive is that they find that for a given number of gauge bosons, there's a maximum number of scalar and fermion degrees of freedom, i.e. a maximum number of fermion and scalar boson fields, which is exactly the kind of thing that you find in the Goldilocks principle. So maybe our model, the model that we're using, asymptotically free theories, is not so bad as a model for fundamental quantum field theories in general. Okay. So points for present purposes are that most sets of kinds, most kinds that you can just pull down off the shelf and form little set sets of, the vast majority of them are not going to conform to the Goldilocks principle, right? So again, to take QCD, there's many more. There are many more QCD Lagrangians that have 16 or fewer fields than have more than 16 fields. That seems like an obvious point. Many more. Okay, so most sets of kinds will not conform to the Goldilocks principle. So this constraint that the Goldilocks principle puts on matter content is non-trivial. Okay, now what exactly you mean by non-trivial is going to be actually, I think, very important in the last analysis of the power of this argument that I'm going to give you, that we can explain the fundamental. However, we should also note that imposing compatibility with the Goldilocks principle does not pin down the fundamental kinds uniquely. You've got some latitude in there, right? You could have up to 16 kinds. That's a fair bit of latitude. One thing, like I said, what's worth thinking about is whether, could we be in a situation, maybe this is the case for all I know in asymptotically safe theories, where you can not only restrict but also pin down the number of the possible combinations of fields uniquely. It turns out there's only one possible set of kinds that could stay consistent in that kind of limit, in the relevant limit, in a situation in which the couplings don't disappear completely. So this is a possibility that I think we should at least think about, and also think about what would happen to the argument that I was to give you if so. Okay. So my claim is going to be that this Goldilocks principle implies that brutalism about fundamental kinds is wrong, right? It's not the case that you can give no explanation of why the fundamental kinds that you find in the world are the kinds that they are. That's not a brute fact about the world. It's one for which a partial explanation can be given. Okay, so this is going to go quickly because it's not complicated. So, first of all, the first thing we need to concede is that what sort of explanation that's afoot here is not obvious. Right? If physicists are going to explain the fundamental, what sort of explanation is not going to be obvious? They're going to use as not obvious, right? There's something very weird about that notion. As such, it's not obvious how to go about securing that there is genuine explanation here. So what seems pretty clear is it's not causal explanation, right? Sets of fundamental kinds are not events, or at least, let's just say they're not events. Also, it doesn't seem like it's going to be a grounding explanation that we get from metaphysics, or at least not obviously, because the stuff is fundamental and thereby not grounded, presumably, so it can't be grounding explanation. I'm glossing over some subtleties here. However, it's plausible that to me there's something that deserves to be called metaphysical explanation of food here, right? You know, fundamental kinds carve at the joints. You know, I've talked about fields having essential properties and so on. I've used a lot of metaphysical language, right? Maybe there's some kind of metaphysical explanation here, even if it's not grounding, right? Even though people think grounding has a kind of a monopoly on metaphysical explanation, there seems to be something here that deserves to be called metaphysical explanation. It sort of smells that way. Ditto for some kind of mathematical explanation. Mathematics is doing so much of the work here. So what I suggest we do to try and argue that there's some explanation that can be given of the fundamental kinds, is that we look to the philosophy of science for the relevant formal aspects. Okay? and then look to the literature on the metaphysics or literature on metaphysical or mathematical explanation for the relevant something else. So if there's one thing people accept about explanation, it's not just characterized formally, right? That's the problem with supervenience. Like, not mere modal correlation or mere entailment does not suffice for explanation, right? You might be able to prove Gödel's theorem and have absolutely no idea why it is true, what it is about the natural numbers that makes it true, right? Just proof, logical explanations, modal correlations are not enough for explanation. There needs to be something more, and I recommend that we look to that literature for that something more. So why do this? Well, what's clear is that we seek some form of indeterministic explanation. I want to be able to explain what the kinds are without being able to say that I know exactly what the kinds are. All I can deduce is sum them up to some, within some constraints. I can't pin them down uniquely. And it's only in the philosophy of science literature that you seem to find indeterministic explanation. So here's some quotes from a bunch of people in this literature. There's Tobias Welch, a student of Jonathan Schaffer. There is no metaphysical analog to statistical explanation. The laws of metaphysics are deterministic. Rubin, I do not think there are any non-determinative explanations other than those which arise on the basis of explanation by non-deterministic causes. Okay, so no mathematical, no metaphysical explanation, only scientific explanation. Schaffer, there can be indeterministic causation, but not indeterministic grounding. Now, no argument is ever given for these claims. I think these claims are wrong. But the point is just, I don't think we're not going to be helped by looking at the metaphysics literature for the explanation that we like. It doesn't have the right, these explanations don't exist. So we should look to the philosophy of science literature for some stuff on indeterministic explanation. Now, the most obvious place to look is the literature on probabilistic explanation, right? That's where the most developed frameworks, explications of indeterministic explanation are. But that's not going to be relevant here, just because I haven't talked about probabilities. I'm not in a position to put a probability metric on sets of kinds consistent with the Goldilocks principle. Nobody is in a position to do this. Certainly not me. Okay, even if we knew what all the combinations of kinds were, somehow we had access to what the possible fundamental kinds are, and we could do some combinatorics, why do we assume that that each of them is equally probable or something like that? We're not in a position to do it. So we have to go somewhere else. So the other place, so there's at least one other place I can find in the philosophy of science literature on indeterministic explanation, and it is Hempel's notion of partial explanation. Okay? And I'm going to convey what this is by an example, which he does too. So the first thing to say is really, what's partial explanation is not a hard concept to get your head around. Go back to Hugh Mellor. He says, we call for explanation when there is a gap between knowledge of what is and what must be. Okay, so a priori, there's all these possibilities that are open to you. You know that actuality is just this one way, but it seems like it could have been all these other ways. If conditional on some claim that's going to serve as your exponents, it turns out that all these possibilities are shut down to just this one here, the way that the world actually is. You have a total explanation. If you manage to just rule some of them out, but not pin it down to one, reduce it to one, you have a partial explanation. That's all that's going on. Okay, so to communicate this, Hempel uses this example of Freud's passage of his psychopathology of everyday life. Okay, so he says, in this context, Freud offers the following explanation of a slip of a pen, which I summarize. So Freud describes a situation in which he's short of papers, patients, right, is getting a bit skint, a bit bored. He hears that somebody's booked in for an appointment with him on the 20th of October, but he notes her upcoming visit in his calendar under the 20th of September. And he says, it was not difficult to explain this anticipation as the expression of a wish. Namely, I wish that I had patients around me just now. Okay, so Hempel says, clearly the formulation of the intended explanation is at least incomplete in that it fails to mention any laws or theoretical principles that could be held to explain Freud's slip of the pen. So this is what Hempel calls an elliptical explanation, where you just suppress the major premises of your argument. You're giving an elliptical explanation. However, the general theoretical considerations Freud presents here and elsewhere in his writings suggest strongly that its explanatory account relies on a hypothesis to the effect that when a person has a strong, though perhaps unconscious desire, then if he commits the slip of a pen, tongue, memory, or the like, the slip will take a form in which it expresses, and perhaps symbolically fulfills, the given desire. But clearly, such expression and fulfillment might have been achieved by many other kinds of slip of the pen than the one actually committed, right? You get the idea. In other words, the exponence, i.e. the desire to fulfill a wish, does not imply, and thus fully explain, that the particular slip, say S, which Freud committed on this occasion, would fall within the narrow class of acting, say W, of acts which consist in writing the words Thursday, October the 20th. Rather, the exponence implies only that X would fall into a wider class, say F, which includes that W as a proper subclass, and which consists of all acts which would express and symbolically fulfill Freud's subconscious wish in some way or other. So, the argument under consideration might be called a partial explanation. It provides complete or conclusive grounds for expecting the slip to be a member of some broad class, and since W, the act committed, or the class of acts committed, is a subclass of F, it thus shows that the exponentum, i.e. the slip falling within that subclass, accords with or bears out what is to be expected in consideration of the exponents. By contrast, a deductive nomological explanation may be called complete, since the exponents does here imply the exponent. Okay? So, it'll be pretty, formally it should be clear that our situation here is the same. We want to explain why our world W belongs to the class of worlds with a certain set of fundamental kinds. Right, our exponents, right, that the fundamental entities are quantum fields, implies only that that set falls into the class of kinds compatible with the Goldilocks principle. As such, our argument might be called a partial explanation. It provides complete or conclusive grounds for expecting W to be a member of those sets compatible with the Goldilocks principle. And since Fk, the set of actual kinds, is a subset of that, it shows that the exponentum accords with or bears out what is to be expected in consideration of the exponents. Formally, the situations are the same. Okay? It seems that we have a partial explanation. Nevertheless, we know that when it comes to explanation, the mere satisfaction of a formal schema is not enough. Either in the deductive nomological model, in which formally you have the flagpole, the shadow explaining the length of the flagpole, etc., nor in metaphysical explanation. Right? So, in any world in which you get Socrates, you also get the set containing Socrates. But in any world in which you get the set containing Socrates, you also get Socrates. So if it's just in terms of modal entailment, we could use Socrates to explain a singleton, or vice versa. But intuitively, the metaphysicians say the explanation only goes from Socrates to the sets, right? Socrates' existence doesn't depend on the existence of sets in any way, right? So the point is we have to add something else to a formal schema. Well, I won't read this out. Basically, what people say in the case of grounding is that, you know, when you have a case of symmetric sort of existential dependence, what makes it the case that one thing grounds another? Namely, some fact about the natures of the thing involved. Socrates' nature doesn't know about sets. But Socrates' singleton, the nature of that, knows about Socrates. And it's in virtue of these facts about the natures that we get this explanatory asymmetry. That's the idea. So, just looking at the grounding literature, it seems that when inferences follow from facts about natures, although just mere facts of deductive entailment don't themselves amount to explanations, when they follow from facts about the natures of things, then yeah, you are in a position to say that you have an explanation, at least according to metaphysicians. So I say this means that my argument is entitled to be called, my partial explanation is doesn't just formally have the properties of partial explanation, we can call it an explanation. And we can see that by looking at the content. So here's the argument. I stipulated that the fundamental kinds are all kinds of quantum fields. I said it's essential to them to evolve unitarily. I didn't explicitly say this, but let's say the fundamental level is one in which the fundamental kinds accord with fundamental laws. That seems reasonable. Fundamental laws are those consistent in the infinite energy limit that follows in quantum field theory. From the fact about the nature of quantum fields, fundamental laws of evolution must be unitary. Maybe I don't need to explicitly say that. What we derived very quickly yesterday is that laws featuring a combination of kinds not satisfying the Goldilocks principle are not unitary in the high energy limit. Their predictions blow up in violation of unitarity, right? They have to be consistent with the Goldilocks principle for that not to happen. Therefore, whatever the set of fundamental kinds is, it must belong to the class of combinations compatible with the Goldilocks principle. Okay, so that's the argument. Let's look at the content. First of all, look at this premise 6. Now, presumably this fact that the laws featuring arbitrary combinations of fundamental kinds do not respect unitarity, and hence in the infinite energy limit, is a mathematical fact. Okay? So I'm just going to read a little bit. To see this, note first that not every fact couched in mathematical language has a mathematical as opposed to, say, a causal explanation. Right? If you're talking about how many strawberries you can sort of divide between bowls and stuff, it's not clear that you need to make recourse to abstract mathematical facts. It's just the facts about the constitution of strawberries and so on. Right? Because in general, those mathematical facts could just be encoding functional relationships between certain physical causal properties that are doing all the real explanatory work. Here, however, mathematics is employed in a sort of impossibility proof that shows there is no possible physical system that could embody the feature in question. Okay? So this can't come from facts about physical stuff, right? It seems to come from mathematical facts themselves. It's also obvious that without this premise, the argument would not be valid. Thus, if, as people have defended, we take a mathematical explanation to be an explanation containing at least one mathematical element that is necessary to ensure the success of the explanation, then it seems that our explanation is at least in part a mathematical explanation. Given that it also makes explicit appeal to facts about natures, right, it seems to have the features of a metaphysical explanation as well. So, this thing that I've given you, it has the form of a partial explanation, it has the form of a partial explanation, it has the hallmarks of a metaphysical and a mathematical explanation. Given that, for me, mathematical physics is a kind of admixture of metaphysics and mathematics, that seems exactly right. And so what I claim is that we have here we have a partial explanation of what the fundamental kinds are, right? And hence it's just false that the fundamental kinds have no explanation whatsoever. Okay, so there's a bunch of, I'm going to basically leave it there. There's a bunch of objections that we could make to this. The most obvious is, were it to be the case that you can deduce this total explanation of these fundamental kinds, like were the explanations get better and better, and the gap closes down to 1 so that we have a total explanation, it seems to me that metaphysicians might be inclined to say, oh, well that just shows, given that you're able to completely explain this thing, there's nothing primitive about it, it's not a fundamental element of your ontology at all. Right, it turns out you thought fundamental kinds were a fundamental fact about the world, but it turns out that it's grounded in other facts. So it's not fundamental. So partly you're in kind of Duhem Quine territory here, right? But what actually, this is a thought that occurred to me in a reading group, this suggests to me, this is an argument in favour of not taking a grounding-based approach to fundamentality and sticking with the joint carving one, because I think only inside this joint carving notion is there room for a claim where you can be fundamental and be explained like physicists think you can. That's it. Sorry about that.
I think we should go have coffee, right?
Yep.